Okay, this is, and I have to look at the book, I forgot. 9.10. Sorry. This is section 9.10, which has to do with bond length and bond order. We're not going to go into a whole lot of detail with it, but I do want you to know one thing once I show you an example. Bond length is simply the distance between nuclei and a bond. Okay, so the structure here shows I have atom A and atom B. The bond length is the distance between those two nucleus of the atom. Okay, bond order is simply the number of pairs of electrons or electron pairs in a bond. So a triple bond has a bond order of 3. A double bond has a bond order of 2. And a single bond has a bond order of 1. Okay? And then basically what I want you to know about that is the larger the bond order, the shorter the bond length. So basically think about these as rubber bands because that's what they are. They're the connection between these two atoms. Okay, so if I have one rubber band, I can stretch my fingers fairly far apart, and it's not very tight. If I put 2 rubber bands on there, the finger's going to come closer, and I can move them a lot less. If I put 3 rubber bands in there, they may come in a little bit closer, and there's basically going to be no movement of them. So the more rubber bands I have, the tighter that bond is held, and the shorter it's going to become. Okay, so question 9.84 asks, which of the following 2 compounds has a shorter carbon-oxygen bond? So what I'm looking for is the bond here between carbon and oxygen. So in this case, this one's a single bond, and in this case, this one is a double bond. So which one is going to be shorter, the single bond or the double bond? The double bond. This one right here is the shorter of those 2. And that's the end of this section.